the International Plant Nutrition Institute. I joined the Institute in 2007. Prior to that, from 1999, I was doing soil fertility research and extension down on the eastern shore of Virginia at the station at Painter. I did this meeting several times. I haven't been back in a few years, and so it's a great privilege to be back with this group. It's always been a very good group, and I look forward to another good program this year. Soil fertility trends in the Mid-Atlantic. What I'm going to be talking about and the data I'm going to share comes from our IPNI soil test summary. We conduct this project every 5 years where we contact all of the commercial and state labs in the U.S. and Canada. Ask for their participation. We ask them to submit all of their soil test data for P, K, and pH. We ask that be mandatory submission, and then other nutrients as available and based on the willingness of the lab managers to participate. As I mentioned, we do this every 5 years. The most recent survey was done and completed in 2015. Just a little bit about how we construct this summary. We ask the labs to provide the numbers of samples that fall within the soil test categories, low, medium, high, however the lab classifies. I'll report that a little bit more detail here in just a second. We ask that they report the data from each state separately. Several of the commercial labs are handling samples from all over, and so we want to make sure that we have accurate representation of where those samples actually came from, not so much where they were analyzed. We had an issue a few years ago where we started getting a lot of lawn and garden samples, so we asked the labs to only send us those from farms. We don't want the homeowner samples included in this survey. We want to, if possible, separate out manured and non-manured fields, going to manage those differently. And we also, this past survey, asked them to start separating out the grid samples. We want to approach that in a little different way statistically in terms of what we say about the changing trends. And then when we call this the 2015 survey, that's basically the 2015 cropping season, which would be samples submitted either in the fall of 14 or the spring of 15. And so that's the time span we'd be looking at. I mentioned we asked them to submit categorically. Certainly all labs use different extraction methods, and so their raw numbers are different. And so we developed this 15 years ago when we started this, where we can categorize these samples regardless of the extraction method, and then we mathematically put them on a common scale so we can compare within a state all the different samples coming from different labs, different extraction procedures, different calibration, different categorization. And so we generalize this in some way that we can report across states. And so when we see the numbers today, the actual number may or may not be relevant to you based on what you're familiar with, but the categorization has been standardized, and so we can say some things in general about the trends. Here are the number of samples were collected when we started this project back in the 2000-2001 cropping system. We brought in just over 1 million samples to be included in the survey. That went up to almost 2 in the second survey, up to nearly 2.5 to 3 in the third, and then in 2015 we ended up with 4.3 million samples included in the survey. And so we're making some pretty coarse observations about some of these data, but statistically when we have a sample size of over 4 million observations, certainly we can be pretty confident that these changes we're seeing and these conclusions we're drawing about shifting trends within a state, we're confident that we're pretty accurate there. And so the way we typically present these data are in terms of frequency distribution. We ask what percentage of samples fall within a certain category. And today when we're talking about the Mid-Atlantic region, that would include these states. Now here's the website. This is an interactive website. And so I encourage you can go on and create your own regions if you're servicing a certain combination of states or sections of states. You can create your own unique analysis data sets. So I've just created this and called it Mid-Atlantic. We don't have time today to talk about specific details from every state, but you're welcome to go on the website, create a username, and look at the data from your state or region at your convenience. You can see this is pretty typical distribution that we'd see, where most of the samples fall here within what we'd call an agronomic target range. This would typically be your medium to medium minus, medium plus, high minus, somewhere in that area. Where we would be targeting for agronomic production down here would be those we'd consider to be deficient, in this case in potassium, and then getting on out here to excessive soil test levels. You can see that I mentioned the 4.3 million samples, just over 500,000 coming out of the Mid-Atlantic region going into that. You can see the numbers have followed the increasing sample trends, as have into all of North America. Now we can make some rough estimates where we see the numbers of samples over the 4 surveys have tended to increase here while decreasing in the deficient and decreasing in the excessive. But it's difficult to draw conclusions over time just from looking at frequency distribution data. So what we did is we were able to do a regression over time, which will summarize the change within a category over years. And so we can be able to see whether we are increasing statistically the number of samples within the target area or decreasing inside or outside that range. And so in terms of what we would say would be an agronomically favorable trend over time for a state or region would be an increasing number of samples within that target range. And the way we've defined target for this presentation is within the medium soil test category, where you'd have a high probability of response to a fertilizer application and, again, a probability of loss without fertilizer, so about 50-50. So that's our target. And again, that number varies from lab to lab based on their calibration data. And so again, this is a generalized range. To be more specific, you'd have to just focus on your single lab. But in general terms, this is what we'd be looking at, would be an increase within the target range, fewer numbers of samples beyond that, and then certainly fewer below that sample. Conversely, if we're seeing trends of increasing numbers of samples below the target range or increasing numbers here, samples falling off, then there's some sort of mismanagement going on. Either we're over-fertilizing, moving the percentage of samples outside that range, or we're under-fertilizing, seeing too many samples falling off. Some general trends that we see moving through the target range would be one of depletion, where we'd have a generalized trending down toward more samples testing lower over the years of the sample. And then the flip side of that would be enrichment, where we'd see a tendency for all the samples to be shifting higher percentages into those higher soil test categories. So when we look at data in this regard with the Mid-Atlantic, what we see in terms of soil test potassium is just what we would hope to see. Over 15 years, we've seen a significant increase in the percentage of samples submitted to the survey within that target range for optimum agronomic production, a decrease in the percentage of samples below that, and a decrease in those samples testing above. So this is exactly what we'd hope to see in terms of how we're managing fertilizer potassium in the Mid-Atlantic. Now let's look at some by-state data. In terms of Virginia, again, I mentioned these numbers are generalized based on the ammonium acetate equivalent, so the numbers may or may not make sense themselves, but in terms of Virginia Tech recommendations, this would be the general target range we'd be looking at to have the bulk of our samples coming into. In the case of potassium, over the 15 years of the study, what we see in the case of Virginia, and again, these are commercial samples and tech recommendations, we see a general trending down toward depleting soil potassium reserves, or increasing rather. We're decreasing the low numbers, but we're increasing up through the target range and outside. The concern here is that we're also picking up higher samples well out into that high and very high range. And so we are building up soil test potassium in Virginia beyond what we'd consider to be the target recommended area. In the case of Delaware, Again, just looking at the frequency distribution, you can see very similar things where we're tending to decrease in these and increase here. And when we look at the categorical change, again, very similar to Virginia, increasing soil potassium levels through that target range and continuing to increase on outside those, in those higher soil test levels. Now, this is really not a huge concern for me agronomically, because we have a lot of growers that do target that high soil test level, and then they want to move into some sort of maintenance program. But what happens when we start seeing it coming on out here, that would suggest that maybe we do need to begin to look at being more efficient with some of our potassium management. Case of Maryland, similar trends that we see, the bulk of the samples coming in that target range. But in the case of Maryland, we just see that build up out here to the high categorical range. Nothing else happening here. So we'd say in terms of Maryland compared to Virginia and Delaware, Maryland would be more of an agronomically favorable trend because we're not seeing the increases all the way out into the high and very high. Now, another way to look at this is, what does this mean in terms of the percentage change of samples that are testing below critical level? And the critical level, again, I told you would be, that's identified by the state labs. Again, commercial labs have their own recommendations. The data we show is based on the state lab recommendations. So as I mentioned, we were increasing soil test K in all three of the specific states I mentioned. Maryland could possibly be more agronomically favorable based on the lack of increase beyond high. But if we look at the states that we've been talking about, Virginia, even though we're increasing the soil test potassium in general, we had 5% fewer samples tested below critical levels, but we actually had an increase in Maryland of 2%. So even though we're building up in a favorable way, we still got 2% more samples. And again, remember this buildup, these trends we were looking at were 2000 to 2015. In just the last 5 years, we've actually had more samples come in from the state of Maryland testing below the critical level for potassium than we did in 2010. Just looking around some of the other regions in the world, see we've got a lot of samples down here through the south. A lot more samples testing deficient in potassium in 15 than we did in 10. We saw the same type trend from 5 to 10, and the issue was, back when fertilizer got so high price there in 2007, 2008 especially, a lot of people just quit putting potassium down, but the soil test levels were high enough that they didn't see the drop off in yield. But eventually over time, we were able to start picking up these decreases in soil test K, and I'll talk a little bit more about that when we get into some of the agronomic stuff. Another way to look at this is what percent, that was the change from 2010 to 2015. Well, what percent of total samples coming in are testing below critical? In Virginia, it's about half. So 50% of the samples that come in, we would make a fertilizer recommendation and expect about a 50% probability of lost yield without applying that fertilizer recommendation. Maryland, only 18%, about a third of the samples. In Delaware, Pennsylvania, also about 30%. Jersey, about 30%. Down here through the south, very high probability of yield loss or response to fertilizer K applications. Not surprising considering the soils we're farming down through the lower coast, southern coastal plain, mid-Atlantic coastal plain. We tend to get we still got a lot of sandy loams up through here, but then we get out west, not so much. Here in the Delta, we got some issues going on there, particularly down in Louisiana. But you can just look and see and spend some time at your own convenience. Another tool that we have at IPNI is called a nutrient use GIS. This is a spatially relevant analysis that we can do, removal to use ratios, balances. What I'm presenting here is the K balance. Now 2012's the most recent year we have. We construct these every 5 years based on the ag census data. And so we're waiting for the 2017 data to become available. Should be spring of 18 or so, and then we'll be able to update these figures. But this 2012 data is useful for us because it coincided with our 2010 soil test summary and also that big fertilizer use drop-off that we saw in the late 2000s when the fertilizer price got so high. And so red would indicate a negative balance, meaning there's more potassium being removed in the harvested crop than is being applied through fertilizer or manures or legume contributions in the case of nitrogen. So we look at, this is a much more extensive analysis than our soil test summary because we're including animal manure inputs in this and other crop residue contributions. And so you can see we've got a deficit here in the delta up through the central plains here. If we zoom in on the mid-Atlantic, you can see this yellow here in the eastern shore, Virginia and Maryland, that's about neutral. And so we're pretty even, at least in terms of the 2012 data, in terms of potassium inputs and removal in the harvested crops. Pretty neutral. You can see we've got a negative balance up here in the upper bay, and then a little bit of a positive balance here in that part of the Delmarva. Now this is by county data, but it looks like this because there's an urban masking. So one of the issues that we get into is that we use our fertilizer input based on APCO sales data. And so a lot of times we get concentrated area in not such heavily agricultural area, and so we mask those areas and try to get a little better picture on exactly where that fertilizer's going out. So that's some of what's going on in different parts of that map. But again, this also is free access. You can log on and again create your own maps. You can look at it by crop, you can look at it by watershed, you can create for example, a potassium removal map for corn, nitrogen removal, NPK by county, by watershed, by state, however you want to look at it. Again, interactive and free to use. Moving on to phosphorus. This is pretty typical for the mid-Atlantic, with all the history of animal waste applications and vegetable production out here. Most of the samples, 60 to 70% of the samples coming in are testing very high in phosphorus. This is not a surprise to us, but we can still look at what's happening down here in the agronomic trend. Over time, we're not picking anything up. And a lot of that is because the heavy weighted percentage of samples out toward that very high level. And so we're not picking much up that's happening. The only thing that's happening is, as I mentioned, to be the increase in number of samples. Again, this is up to, we've come from 80,000 15 years ago up to about 500,000. A lot of this jump, I didn't mention this, again, when fertilizer price got very high, we saw a big spike in the number of growers taking samples. And I think we as consultants and extension agents did a good job at that time of really communicating the importance of a good regular soil test program, and we've seen that just continue to grow over the years, even as fertilizer prices have come down some, and now with crop prices being low again, the attention being paid to the soil test information, I think, is very encouraging, and that's also being reflected in the number of samples coming in. Looking at Delaware, again, exactly what we'd see. 80% of the samples coming out of Delaware test very high. In terms of changes and trending changes, we are seeing a trending depletion, which again would be expected based on the nutrient management and P index that we've seen happen over the last 15 years, that we would expect these numbers to come down. We've still got a little increase, but a lot of what we see here is just an effect of more samples coming in. When we get more nutrient management plans coming in the early part of the survey year, mid-2000s, most of those new samples coming in were the very high soil test category. And so I don't think this is indicative of an increasing soil test. I think this is just a factor of the volume of samples probably coming in here in the high soil test category compared to the early years of the survey. But down here in the agronomic area, certainly we're seeing a trend toward depleting. But in the case of Delaware, we are seeing some increase within this target range. And so the general trend is depleting, but we are seeing some still holding pretty steady in that targeted production range in Delaware. Case of Virginia, just looking at frequency distribution, pretty significant drop off here between the last 5 years of the sample in very high soil test categories. But again, compared overall, not seeing it here. But again, same as Delaware, shifting trend toward depletion, but without the growth throughout the target region. So you can see this is shifting right on through that target region to depleted soil test phosphorus. Case of Maryland, again, also huge drop here, 10% from just over 50% down to 40% of the samples testing very high. Again, a result of phosphorus management planning. Similar trend to Delaware, where we've decreased throughout the range, but have actually increased in that target range. So agronomically favorable depletion of soil test phosphorus in Maryland. Looking again at these maps, again, this is the change in the percent of samples over the last 5 years. So this kind of matches what we've seen. We saw an increase in the number of samples coming in from the state of Maryland of 13% more samples testing below the critical level in 15 than there were in 10, about 9% in Virginia, very little, only about 2% fewer samples testing below in Delaware. And look up through New York, Jersey, you can see those numbers. Not much going on here in terms of phosphorus in the lower coastal plain. You got a pretty big jump here again in that Delta region, big up here in the Lake Erie watershed. So again, wherever we see concerns with water quality, we tend to see the biggest increases in samples coming up, which is a direct result of nutrient management planning. What does this mean in terms of the percent of samples testing below critical? Again, still even about half, about 50% in Maryland increased, 13% more samples over the last 5 years tested deficient, but they're still only about 50%. Again, I mentioned this Delta area. Most of the samples coming in through there are coming with a P fertilizer recommendation. About half to a third throughout the lower coastal plain, 40% in Virginia. Look at P balance, again, kind of what we see in terms of the soil test summary, where we have a negative balance in the Delta up into the Lake Erie watershed and Midwest. Mid-Atlantic, again, negative balance here on the eastern shore of Virginia, meaning we're removing more P than we're applying, which includes animal manure. And this is interesting. As I drove up from Norfolk yesterday, saw a ton of new chicken houses going up. Looks like the poultry industry, Mark Ryder was telling me that these new houses are going to hold 60,000 birds, and that I don't remember how many millions more birds they're expecting to have there. But this issue of P in the animal manure is going to continue to be an issue for us out here on Delmarva. And so it already, at the negative balance, these type tools actually give us a good basis to begin to work from in terms of how we're going to manage all this new manure that we're going to start finding. And this by-county data will help us identify some of those areas where we might be able to increase some land application. Certainly, just like there was back in the late 90s, early 2000s, their transportation is an issue. But here in the Upper Bay, we're currently sitting at a negative P balance. Again, pretty neutral through this part of the shore. And then some negative balances down here in the Tidewater area. This was a big concern out here because we were already, even though we've got negative P balance, we were very high in soil test P. So we can run negative for a few years, but this was a big concern, all this red out here in the Midwest, because they didn't have the P reserves built up that we did out here on Delmarva. And so in terms of fertilizer management, this is an area where we really are working to make sure that growers are not missing opportunities or losing yield due to lack of phosphorus fertilization. And so in general, what we're seeing here in the Delmarva, as a whole, very encouraging agronomic response in terms of P and K, pulling down a lot of those very high soil test levels, moving down through in all three of the states we focused on. Got some nice buildup in those target areas in Maryland and Delaware. Virginia, we're moving on through, but again, about 50% of the samples we see coming in we're recommending phosphorus on. In the case of potassium, Maryland is the only one that is really showing what could be considered agronomic. We're increasing potassium throughout that range, but again, these ranges are generalized. For us to say specifically, we'd have to look more at local calibration recommendations in terms of what the labs are recommending, because if you compare state lab recommendations and commercial lab recommendations, sometimes there's some difference there, and it just depends on the philosophy as well as the actual calibration data. And so a lot of that is very site specific. So you'll take this for what it is. This is a generalized 30,000 foot view at what's happening, but in general, this is what we see, what we conclude is happening in terms of soil test P and K in the Mid-Atlantic. Now, how do we use these data to help us make some fertilizer recommendations? Because the situation we find ourselves in, whenever fertilizer prices get high or crop prices get low, is that the first place growers start to look to cut input cost is typically fertilizer. P and K, lime, seed, not so much. Nitrogen, usually pretty consistent. Chemicals are going out. And so where the growers are looking to cut costs are on P and K. And so we can look at a few different scenarios and use these soil test summary data and some other agronomic information to help these growers make better decisions. And so what happens if fertilizer rates are cut back? Well, it depends on a lot of things. Where did you start? What are we talking about specifically? Well, what if a farmer just says, well, what happens if I don't fertilize? Well, again, it depends on where you start. And we look back at this map. If a grower from North Carolina asks me, well, what happens if I don't put out potassium? Well, 70% chance you're going to lose yield without knowing anything about that farmer's specific data. If he doesn't have current soil test level, if he's just been making traditional applications, something in the starter, well, based on the data we have, we could say with pretty confidence, well, there's about 70% of the soils that come through the lab need potassium. And so you probably need to get a soil test if you don't have one. If you do, you're probably going to be in that low to medium range. Up here in Maryland, if you get a farmer that says, well, do I need to put out potassium? Well, maybe, maybe not. You probably okay. But again, if a farmer doesn't have the soil test available for that farm, it's a good encouragement to say, look, you probably need to start getting one, because most all the samples, or half, need potassium. So we can make some generalized conclusion about the probability of needing some. And then we know how much it takes to make a crop. And one of the things that a lot of growers don't understand is the difference between removal and uptake of these nutrients. Is that we talk a lot in nutrient management planning and in the balance work we do in terms of removal. But that's just the amount of nutrient that comes off in the harvested crop. That's not the total amount of nutrient that goes into that crop to make that grain. So for example, 150 bushel corn, we need to get 210 pounds of K2O into that plant. A lot of us are, we're growing 225, even 250. So you figure increase that by 50% up to 225, we got to get 300 pounds of K into the crop, whereas only about, at 150 bushels, about 40 to 45 pounds of that is going to come off. And so if we're just making our estimate based on removal, it's like, oh yeah, I'm good, I'm only going to take off 40. Well, you got to get 200 into there. And so that's something we got to be responsible about communicating to the growers, is making sure, well, if you want to cut, you got to remember that uptake is the number we need to be thinking about in terms of plant availability of these nutrients. Now that's in a medium, but if the soil test level is high, we get a report back, we see the green bar on the report, soil test level's high, but they're still recommended some fertilizer. This is typically a maintenance application, often based on expected yield for a region. A lot of states calibrate this way based on soil types or the yield goal that the farmer submits with the sample. Different labs vary in this, but we see most labs still making some nutrient recommendation at the high level. And so the farmer's asking, based on crop prices, do I really need this? Can I skip this application? Well, again, it depends. This is what we saw. I know, for example, there was a field in Missouri that a farmer was at a meeting, and he hadn't applied potassium in 8 years. From 10, he said nothing ever happened. Well, I don't know what his soil test level was, but if he keeps taking corn and beans off that field every year, eventually it's going to go down. We know for certain it's like a checking account. You can keep writing checks, nothing happens, but eventually if you don't put some money in, you're going to bounce a check. It's the same way with yield response. Eventually, you're going to remove enough nutrients that the additions are going to have to be made, or you're going to lose yield. Now we get to this issue of nutrient removal, because now we're trying to do some sort of nutrient balance. And we have these charts available, and I have two different ones shown up here, because what a lot of people don't understand, and we got into this back in the late 90s when NRCS and other groups started trying to, we started developing the P index and everything, so we wanted to know what's nutrient removal. And what we found is that it varied regionally. And so you have to be conscious of what are the local data saying about nutrient removal. For example, a lot of them are very close. But in some, in the case of corn at 150 bushel, you're only talking about, if you use Midwest data or you use Southern data, you're only talking about a difference of, I don't know, maybe that calculates out to be 6 or 7 pounds. But some of these, some of these potassium numbers, 1.3 versus 1.4 on beans, you can get up there sometimes close to 10, 20 pounds difference. An application, a noticeable application difference in terms of what you would remove. If it's 10 pounds, you can a lot of times see, once you get up over about 10 pounds difference, you can see that in terms of crop response to a fertilizer application. So make sure that you're using the right tables for the data. So that's going to happen. What's uncertain is, does soil testing even pick these differences up? Because nutrients put in with fertilizer and nutrients taken off in the crop are not one-to-one in terms of how they affect the soil test number. Now, we do our balance in terms of nutrient in versus nutrient out, but that's independent of what's happening in terms of the soil test. Some states have worked out rules of thumb, a certain, so many pounds of nutrient removed makes a 1 unit change in soil test, or a 1 pound, or so many parts per million. Again, those are, those are generalized, but it's very hard to determine the effect on the soil test number if you're just trying to say, well, okay, I'm probably still in the medium category. There's a lot of stuff going on in the soil, biologically, chemically, physically, that affects the plant availability of a nutrient in a given year. In fact, this potassium is one that's very highly susceptible to temporal changes in the field. I was just visiting with a grower in North Alabama 2 weeks ago, and she was complaining about her lab what the numbers, she was getting pH numbers back, and they were a unit difference from one year to the next, 1 unit lower, and she had limed the year before, unit lower the next year. It's like, what's going on? This lab is screwing everything up. But turns out one set of samples had gone in the fall, the next had gone in the spring. And so you can see what soil moisture difference and time of year. If you're sampling in the fall or you're sampling in the spring, you get a lot of seasonal fluctuation. And so this is something that we've been trying to educate consultants and growers on for years, is that we need to be consistent. Logistically, we understand that it's not always possible, but what we have to communicate is that these differences are due to natural fluctuations in the extractable amount of nutrient that these labs can come up with, that it's not a screw up on the lab's part, that it is just natural temporal variability that we have to be aware exists, especially if we're trying to work on a balance sheet approach to minimize the amount of fertilizer application we have to make if we're looking at economically challenging times. We have to recognize that this temporal variability does exist. Okay, my soil test indicates that fertilizer is needed to prevent yield loss. I accept that I'm in the medium category, but man, that bean price is bad. I didn't get it contracted. Fertilizer's high. How much yield are we really talking about here? Okay, so again, that's hard to say because the temporal variability and weather often drives the yield response to fertilizer and the effectiveness of the fertilizer. But I built this table based on different labs. I think I had maybe 11 different labs. Virginia Tech was included in that. I didn't have any from Maryland or Delaware, but Tech, Carolinas, down through Oklahoma, Florida, built this table. And this is a generalized probability of response to a fertilizer application at the different soil test categories and the expected yield loss without fertilizer. And so if your grower's in the medium, in that target range that we talked about, and he has a recommendation for fertilizer, about 50% likelihood that it's going to respond, and if you don't apply it, you're looking at up to possibly as much as 25% yield loss. In general, throughout the South and Mid-Atlantic, that's what we'd be looking at. At high, 20 to 40% probability, but we're only talking about maybe 10% yield loss. In fact, I personally have never seen a response to fertilizer in a high soil test except for phosphorus on potatoes. In all my years of research on the eastern shore, on a grain crop, I never saw a yield response on a high fertilizer test, but I did see some on a starter phosphorus application in potatoes. Low, if you're at low, you got a 60 to 80% chance, more likelihood than not, that you will see a yield increase to the fertilizer and could lose as much as 50% of the yield if you don't apply it. And so this is in general, but we can use these data to guide our growers that if you're medium, probably I'll put it high, you're probably all right. Go ahead and skip. But again, depends on how high you are. You saw on the Maryland data where we're still building up into that category. So again, we would think that's probably a more reasonable target, assuming that there's been responsible agronomic recommendations going on in Maryland. We would expect that to be a more accurate target. So again, we can advise accordingly. Another issue we get into in terms of risk management to fertilize or not to fertilize depends on the uniformity of the field. And so certainly, the risk goes up. As the soil test begins to drop, our risk of losing yield goes up. And so we have these targets we're talking about. Well, when we're talking about a composite soil sample from a whole field, this is not precision ag. This is just general, uniform, whole field management. We have a target. We have to make some assumption that there's some uniformity here if we're not managing this field spatially. And so we have a target. If we have known variability, spatial variability within the field, and we want to manage that field uniformly, then we have to push that target on out toward that upper end to account for that variability within the field. And so when we have that target range, certainly if we're medium, medium's probably a reasonable risk assessment for us in terms of fertilized or not fertilized. We're probably more on that 50-50. But if we have a lot of variability within that field, then we start looking, well, we're more up closer to that 60% probability of response, closer to that 25% yield loss possibility. And so in that case, we would, good opportunities for variable rate fertilizer application. We're seeing a lot more of that throughout the Mid-Atlantic. A lot of growers I'm still working with over in the coastal plain around New Kent and Charles City in Virginia are going to the variable rate PK and lime, variable seeding in terms of optimizing nutrient inputs based on seed population changes in their corn and soybean based on yield potential. So a lot more precision technology being used, which is helping us in terms of risk management, especially as we see prices becoming unfavorable for fertilizer applications. So how do we get the greatest return on investment from the fertilizer we do apply? Well, all we're talking about today is rate, but rate is just one component of responsible fertilizer management. Hopefully everyone's familiar with 4R nutrient stewardship. I'm not going to go into this, but we can do things with timing and placement and source choices that we make that can help us be more efficient with our fertilizer input other than just cutting back the rate. If we can be more efficient with the timing, in the case of potassium, we have some data that suggest in the low organic matter, low CEC, highly leachable soils that sometimes a split application, we've seen this on cotton, can be beneficial. Certainly we understand what we can do with split applications in nitrogen. Placement of phosphorus, is a lot of work going on here in these environmentally sensitive areas, Chesapeake Bay, Lake Erie watershed, Mississippi Delta. A lot of stuff going on placement. And also placement, we tend to think of placement in terms of banding versus broadcast, surface applied versus incorporated. But we also, when we talk about placement, we're talking about variable rate applications, getting the right amount of nutrient in the right place in the field. And so again, as we look to be as efficient as possible with our fertilizer inputs, source rate, time and place all have to be considered simultaneously. Is there other information other than soil tests that we can use to help us be more efficient and effective with fertilizer inputs? Absolutely. Plant nutrient analysis, tissue testing, in-season evaluation. Again, the precision ag technologies can help us. We see a lot of service providers going to aerial imagery, looking at NDVI maps, either from satellites or UAVs. Some of the canopy sensors are being used in different parts of the country to help guide in-season nitrogen applications. But there are a lot of tools that we can use to complement a soil test program. Now, we certainly don't ever want to get away from soil testing. I mean, we're getting a lot of in-season information. Our ability to generate very inexpensive, high-resolution data is where it's never been before. But we still need to have a good foundation of knowledge about what that soil can provide. And all this talk of precision technology and data-driven agriculture, I'm a big proponent of it, but it will never replace good boots on the ground agronomy. We've still got to be out in the field. We've got to ground truth these things. We've got to scout, and this becomes even more important when economics are unfavorable for production. And so, in summary, what we see happening in general in the Mid-Atlantic is an enrichment of soil test K. However, we still got over half of the samples coming in from Virginia testing below the critical level. We have a generalized depletion of soil test P, which is not terrible based on where we're starting, but we want to make sure that we continue to increase the percentage of those samples within that agronomic target range. We can't just keep pulling soil test P down, or we're actually going to find ourselves having problems in terms of crop response to fertilizer. Maryland and Delaware showing agronomically favorable trends. And so how do we use this information to help growers manage soil fertility, continuing to push for high yield even though prices are unfavorable, for our nutrient stewardship, source, rate, time, and place? We got to think about these all as being interconnected, one affecting the others and being affected by them. And so we make our recommendations based on that. Don't reduce application rate. Yield pays, no matter what the price of crops. There's plenty of data to show that sacrificing yield for economics just doesn't make sense. Every bushel we put in the bin will pay if we produce it in an efficient and effective way. Where we can pull back maybe is on some of these high testing soils. Again, it has to do with the soil test history and the knowledge we have of the field, but certainly if we're looking to cut rates, we've got to restrict it in these high testing fields. And then soil test and consider variable rate. Again, this is a risk management issue. If we have highly variable fields, even when costs are high, that's really where we see a lot of precision technologies start to pay for themselves, are in those tight economic times. So even with the added cost of the grid sampling or the variable rate application, we see that coming back to our growers in terms of a return on the investment, either in fertilizer savings or increased yield by redistributing the same fertilizer rate just into those areas of the field that need it more. So with that, that concludes my comments. I appreciate your attention. And remember, both of these tools, NuGIS and the soil test summary, are available on the websites I've shown. I think this presentation will probably be available after the conference on the website if you didn't get those websites down. But I encourage you to go on there, take a look, and see what your state looks like. Thanks.
We have time for questions. I just want to say that I forgot to announce the tracking numbers. If you need to know, this is CB52623. And any questions, if anyone has questions,
You got a question?
Has there been any effort? I'm really concerned from not your organization, but very high. This is where it's